Welcome back. This is the third lesson recording for IM2 week 7 of distance learning. Now we're going to be considering volumes of cone and pyramids. So how do the volumes relate to solids? We already know. To explore this, we're going to watch two short videos. This first video compares the volume of a cone with a volume of the prism. Notice that they have the same height. And if you compare the base area of this cone with the base area of this prism, you will find that they are exactly the same as well. So let's see what happens. So he's getting the cone and he's filling it with the water, and he's filling that volume of water into the prism. That's the first cone. He does that with the second cone. Again, they have the same height and same radius. And finally the third cone, and it fills up to the tip. Second recording does very similar thing, but this time we are comparing the volume of a rectangular pyramid to volume of a rectangular prism. Notice that again they have the same height. And if you compare the base area of this prism with the base area of this pyramid, you'll find that they are exactly the same as well. So he fills it up. It takes one volume of the pyramid to fill up the prism there, and then the second. I know it looks like he's not filling it all the way to the tip, but that's actually optical illusion. He is indeed filling it up all the way to the top of the pyramid, and then he is doing the same thing with the third pyramid, and look what happens. It fills up all the way to the top. So what are the takeaways from the video? It took 3 cones of the same radius and same height to fill up the cylinder. And similarly, it took 3 pyramids with the same base area as the prism with the same height to fill the rectangular prism. So from here we can come up with a generalized formula. The volume of a prism multiplied by a third is going to give us the volume of the pyramid or a cone. So if you have a pyramid, then you can find the volume of the same base shaped prism and then multiply that volume by a third, and you will get the volume of the pyramid. And likewise for cone, it's the volume of the cylinder. This is the volume of the cylinder, and you multiply that by a third and you get the volume of the cone. So again, the volume of a pyramid and a cone is just going to be a third of the corresponding prism or cylinder, in whichever case it might be. Right, so let's use that to figure out some calculations. Here I have some problems. I would like you to pause this video and try these problems now. And when you have done this, I am going to give you 2 more problems. These are my 2 more problems. Pause the video now and try to find volumes of these 2 solids. Okay, I'm assuming that you've done this, and I'm going to go through the answers. How do I figure out the volume of this pyramid? Well, what is the volume of a rectangular prism? It's just going to be the base area times height. The base area is 3 times 2, which is 6. And the height in this case is 4. And if it was a prism, you would just multiply base area times height, so 6 times 4. But because this is a pyramid, you're going to have a third of that, so that's going to be 8 inches cubed. What about for this cone? Well, we know the base area is going to be pi r squared, so pi times 12 squared, which is 144 pi yards squared, and then multiply that by height, which is 24. That's going to get you the cylinder, volume of the cylinder. But because this is a cone, we're going to take a third of that. So that gives us 1,152 yard cubed. The third problem is a little bit more complicated. We know the radius is 8 feet because we're given the diameter is 16 feet, and we know that the base area is going to be pi r squared. But we do not know the height of this cylinder, this cone. And we only have the slant height, so we have to figure out the Pythagorean theorem to find the h height. And we know that this is 8 and the hypotenuse is 17.9, so h squared plus 8 squared is equal to 17.9 squared. So then using the Pythagorean theorem, h is going to be square root of 17.9 squared minus 8 squared, which is approximately 16. Then putting that value into the formula, you get a third times 64 pi times 16, which comes to about 1,072 feet cubed. What about this solid? Okay, this is a little bit more complicated because it is formed by a pyramid at the top and the prism at the bottom. So the total volume is going to be volume of the prism plus volume of the pyramid. We can figure out the volume of the prism by multiplying the base area times height. So 5 times 3 times 2, which is 30. To figure out the volume of the pyramid, we first need to figure out the height of the pyramid. We're given that total height from the base to the tip of the pyramid is 9 centimeters. And we know the prism takes up 2 centimeters of this. So we know that the pyramid's height is 7 centimeters. So from here, base area of pyramid is going to be same as the base area of the prism, 5 by 3. And volume of the pyramid is going to be again a third of 15 times 7. And then to find the total volume, you're going to add the volume of the prism plus volume of the pyramid, which comes to 65 centimeters cubed. Okay, let's do a little bit of extension work. Okay, so what about oblique cylinder? If I was to figure out the volume of this oblique cylinder, remember volume is the space it takes up. Okay, so consider this. If you have a stack of 20 quarters, is this volume same as this volume? Again, the volume is how much space it takes up. So if I push this and leaned it like so to create an oblique cylinder, is the space it takes up the same? It is. Okay, so that's the discovery. So oblique cylinder has the same volume as the right cylinder with the same base and height. So as long as the base area is the same and the height is going to be the perpendicular height to the base area, then you just need the perpendicular height and the base area. It does not really matter what angulation this oblique cylinder is. So same volume. Yay! Similar idea for oblique prism. Okay, again, the right prism, if I just push this to the right, it will turn into oblique prism, but the area of the base is still going to be the same. So they are again going to have the same volume. And we can demonstrate this with a GeoGebra tool. Okay, so you can see, you can play around with this GeoGebra tool. You can move this around and notice that as long as the two solids have the equal cross-section area, and same height, they take up the same volume. It does not matter what happens. Okay, and you can turn this into slabs. And you'll find this link on the resources. Okay, so again, solids with the same cross-section area at every height will have the same volume. Does not matter what shape it is tilted in. Okay, and that's pretty cool, and it's called Cavalari's principle. Okay, I'm gonna stop it right there.